Welcome to This Explainer. Today, we're popping the hood on Python to figure out exactly how it handles your data behind the scenes. And whether you're writing code every single day or you're just curious about the logic that drives all our modern software, we're going to break down this really core concept using a brilliant everyday metaphor, a smart kitchen scale. It's a super simple visual, but man, it perfectly captures the absolute genius of Python's design. Let's dive in. So before we even type out a single line of code, a pretty obvious question usually pops up. How do you actually tell Python which container to use for your data? See, in a lot of other programming languages, you have to do all this meticulous prep work to organize your data before you can actually do anything useful with it. You have to be incredibly specific right out of the gate. But Python? Well, Python takes this highly intuitive approach that makes your life as a programmer just infinitely easier.
To really appreciate this, picture this scenario. Imagine you're cooking in a kitchen where you have to literally yell, "Hey, I am about to weigh a liquid," before you're even allowed to pour milk into a bowl. I mean, sounds ridiculous, right? But that's exactly what rigid languages like Java or C++ require. You literally have to program the scale beforehand. Python, on the other hand, acts like this ridiculously advanced AI kitchen scale. You don't yell at it, you don't give it any warnings, you literally just place an empty bowl on the scale, drop something inside, and boom, it adapts instantly.
Now, this automatic guessing mechanism actually has an official name. It's called dynamic typing. Basically, dynamic typing is Python's built-in superpower to guess the exact data type based purely on the value you just dropped into the variable. If you drop a whole apple on the scale, it blinks and just knows, okay, that's an apple. If you pour milk, it instantly switches gears and knows it's a liquid. This dynamic typing is the entire engine behind Python's incredible flexibility. Okay, let's mentally open up our code editors and actually watch this smart scale do its thing. We're going to run a little test in 3 quick steps. First, we'll drop in a whole number, which Python calls an integer. Second, we'll pour in a liquid, which translates to a decimal number, or what programmers call a float. And finally, we'll drop in a handwritten note known as a string. And to do this, we'll use a special built-in command called type to force the scale to report back exactly what it's seeing at every single step. All right, step 1. We create a variable, let's call it bowl, and we just drop the whole number 5 right into it. When we ask Python to print the type of the bowl, the terminal spits out class int. Python looked at that 5 and instantly, automatically picked out an integer container. It is literally just like dropping that whole apple onto our AI scale. We didn't have to announce we were using an integer, the smart scale just knew. Now, here's where it gets really cool. We don't even need to go rummaging through the cupboard to buy a brand new bowl for our next ingredient. In our code, we just empty out the old one and pour in a decimal number. Let's use 5.75, which is our metaphorical milk. We assign that 5.75 to the exact same bowl variable. And when we run our print type command this time, the label seamlessly changes to class float. Our smart scale adjusted entirely on its own without a single complaint. Finally, let's dump out that milk and toss a piece of text into our bowl. To do this in Python, you just use quotation marks. You can think of quotation marks as like your sticky label tape. So we type apple pie recipe inside those quotes. The second we drop that text into the bowl variable and check the type, the scale instantly updates to read class str, which stands for string. So think about that. We just threw 3 completely different types of ingredients at this language, and it handled the whole shebang flawlessly, using the exact same container. And this right here? This flexibility is absolutely crucial to understanding why Python matters so much in the real world. It's the reason the language is so incredibly fast and honestly fun to write. Because as a programmer, your only job is to focus on your ingredients. You just focus on the actual data you want to use and the problems you're trying to solve. You never have to waste your time sweating over the containers. Python just hangs out in the background, acting as your highly capable smart scale, handling all the tedious packaging and labeling totally behind the scenes. But before I let you go, let's put this metaphor to the test with a quick trick question. Take a look at these 2 variables. We have ingredient A equals 10 and ingredient B equals 10 in quotation marks. Are these 2 things the exact same to Python? Really think about our smart scale here. And specifically, think about that sticky label tape we just talked about. How would the scale react to these 2 inputs? Well, if you guessed that they are different, you hit the nail right on the head. They are absolutely not the same thing. The 10 without the quotes is a real cookable ingredient. It's a mathematical number you can actually use.
But the 10 with quotes around it, that is just a sticky text label that happens to have the characters 1 and 0 scribbled on it. You can't cook with a label. Which leaves us with one final thought to ponder as we wrap up this explainer. What kind of disastrous bugs do you think happen in software when programmers accidentally try to cook their dinner using label tape instead of actual ingredients?